In this video, we're going to go ahead and briefly cover 4.4 trigonometric functions of any angle, still part of Unit 4, okay, trigonometry. We are going to be referring to our tab 3 from your main trig foldable, just in case you're not sure where that's from, okay? So here's example 1. We have that the point -3, 4 is on the terminal side of theta, and we need to find the sine, cosine, and tangent of theta. Okay, so the tab I'm referring to for the foldable is going to be this one right here. And basically this one tells us all the signs of sine, cosine, and tangent here at the top. Okay, so in quadrant 1, we have the following: quadrant 2, this, quadrant 3, and quadrant 4. Okay, just to kind of give a quick background. Okay, so we know that -3, 4 lands in quadrant 2, okay? And in quadrant 2, sine is positive, cosine is negative, and tangent is also negative. Okay, so just keep that in mind, because if we do have values here, we're going to have to use these signs, okay? All right, so let's start. We do have the answers already. I just kind of wanted to go over them. For this point, okay, what I did over here is I kind of did like a little bit of I showed you where it is, and I showed you how the angle works. You'll notice that this makes a right triangle of sorts, okay, where my x is basically 3, but it's negative because cosine in this one is negative, okay? My y is going to be equal to 4, and that's just basically going from here. X is this, y is that. So sine is defined as y divided by r, where you have your y value divided by the radius. So we still have to find this this radius right here, basically this piece. So how do we find that? Well, we just use Pythagorean theorem, yeah? We know that a squared plus b squared equals c squared. So if this piece right here is 3 and this piece right here is 4, okay, but we're thinking distances, so they become positive when we're doing the actual triangle. We would solve r by taking the square root of the squares of the sum of those. Okay, and if that's a little bit too much, just let me know and I can tell you how we went from here to here. But after we do that, okay, we get 9 plus 16, which is 25. Square root of 25 is 5. So our radius is just 5. So following the definition, y divided by r would just be our 4 divided by 5. And we already saw that sine is positive, so our number should be positive. Okay, same thing with cosine. We take our x value, so -3. Remember, our x is actually negative in that one, divided by r, which is 5. And that comes out perfectly because, again, we see that cosine should be negative. Tangent should be negative. So let's see if we can get that one. Tangent is going to be y over x, so 4 divided by -3. And there is a correction here. I don't know why I flipped it, but this should be -4 over 3. Okay, and that's it. That's how you do that problem. Okay, let's move on to example 2. We have given that sine of theta is 4 over 5 and tangent of theta is negative. That's what this means. Less than 0 is negative. Find cosine and tangent. Okay, so what I did for this one is I said, well, let's look at what's given. Let's figure out where this is located. Okay, so I know that for sine to be positive, okay, well, first of all, this is y over r, so y is 4, r is 5, and it's positive, so we need to find where is y positive. Well, according to my foldable and just in general, y is going to be positive on the top, quadrant 1 and quadrant 2. So I listed them, quadrant 1, quadrant 2, okay? Tangent is supposed to be negative, so now we're going to find where is tangent negative, okay? Well, tangent, according to our foldable, is negative in quadrant 2 and quadrant 4, basically these two quadrants. So we can see that there's an overlap in quadrant 2, and that's why we chose quadrant 2. So you can see here's my triangle, and since we know that y is 4, that means that this piece right here is going to be 4, and r is 5, so that's the radius. So we need x. We need the last part of the triangle, x. So to find x, we have to subtract because we're looking for one of the sides. And when you're doing Pythagorean theorem, anytime you're looking for one of the legs or the sides, that's not the hypotenuse, you basically square and subtract square root. Okay, so 25, which would be 5 square, minus 16, which is 4 square. Subtract them, we get the square root of 9, and x is going to be equal to 3. But since we're in quadrant 2, okay, you know that x is negative in this part, so x is going to be negative 3. Okay, so with that information, cosine is x over r, negative 3 divided by my radius, which was 5. Tangent is y over x, which is 4 over negative 3. Okay, next example. Just a bunch of examples in this one. So here we have evaluate cosine and tangent at the quadrantal angles. I can't say that. 0, pi halves, and pi and 3 pi halves. So I did a really quick, like tiny little picture here just to kind of show us what those are. So 0 is this first one, right? Pi halves is up here, pi is here, 3 pi halves is there. And I just wrote the numbers that are there. So this first one is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, and we're just going to note that the radius is equal to 1, okay, because this is the unit circle in this case. So cosine of 0 would be x over r. So my x value here is 1. So 1 divided by my r is 1, and that's just equal to 1. Cosine of pi halves, we're using the point now 0. Here, I can do this if you want. We can put the point on the side. So this point is 0, 1. So again, my x is going to be 0 divided by my radius. Radius is always 1 for these. 0 over 1 is 0. Cosine of pi, now we're looking at negative 1 comma 0 because that's where pi is at. Again, negative 1 divided by 1 is negative 1. Okay. And last but not least, cosine of 3 pi halves would be 0 comma negative 1. So this is our x. 0 over 1 is 0. Okay. Now we have tangent. We're using the same points, but now we're looking at y over x. So tangent of 0, let's see, at 1, 0, this is x, this is y. We're doing 0 divided by 1, which is 0. Tangent of pi halves, now we're looking at 0 comma 1. This is x, this is y. And again, these points are just coming from the circle. Okay, I'm just rewriting them. So we have 1 divided by 0, which is undefined because we can't divide by 0. Okay. Tangent of pi is negative 1 comma 0, so x, y. 0 divided by negative 1 is 0. And last but not least, we have tangent of 3 pi halves, which is 0, negative 1, x, y. Negative 1 divided by 0. Again, we cannot divide by 0, so this is also undefined. Next example. Pretty quick, hopefully. For this one, I want to give a hint at the top that pi is approximately 3.14 and 2 pi is approximately 6.28. Okay, so we're going to let theta be an angle in standard position. In other words, it's going kind of counterclockwise, and we have the initial and the terminal side in that area. Its reference angle is the acute angle theta prime. So this just means like the kind of like the complement of it. If that makes any sense. Formed by the terminal side of theta and the horizontal axis. So what that means is after we have our angle, we're looking at the ending side, the terminal side, and the x-axis. So I kind of did pictures for all of these just so you can kind of see how it works. Okay, here we have 300, I'm going to cover this for now, 300 degrees. So the first thing we're going to do to find the reference angle is find 300 degrees. So here's my picture. It starts at 0, goes all the way around, and we know this is 360, so 300 is somewhere about right here. Okay, so this little pink thing represents 300. And we're trying to find the angle that is basically between this terminal side, so this right here is my terminal side, the ending side, and the x-axis. So you need to decide, is this closer to this piece of the x-axis or is it closer to this piece? Well, it's closer to this one. So all I did is I took this number 360 and I subtracted the 300, which gave me 60. Another way to think about it is how much more do you need to get to that x-axis? Well, 300 plus 60 is going to give me that 360. So my reference angle is 60 degrees. And these are very useful because sometimes when we're calculating stuff, it's way easier to work with 60, which is in our foldable, than it is with 300. Okay. We have another one, 2.5. Okay, and this one I have another hint that I put. If there's no degree, we have to use radians. And that's why I have that hint about, well, what are radians in terms of decimals? Okay, so we know that pi is about this and 2 pi is about that. And I chose those two because, well, those represent the ends of the x-axis. Okay, so 2.5 radians. 2.5 is less than 3.14, but it's I think it's a little bit, it's way less than 6.28. So it's probably going to be on somewhere up here. Okay, 2.5. So there it is. And if you're not sure where it lands, you can also calculate pi halves if you wanted to. Let's see, it'd be 3.14 divided by 2. I don't even know what that is, 1 point something, whatever, 1 point something. So 2.5 is obviously bigger than pi half. So it's somewhere here. Once we've drawn the angle, so this right here is my 2.5 radians, my theta. To find theta prime, which would be whatever's left over, well, we can see that we need to do pi minus this part, right? So I did that. I did pi minus 2.5, and it came out to approximately 0.64 radians. So this reference angle, theta prime, I guess I should probably put that, huh? Theta prime is equal to 0.64 radians. Same thing for this one over here. Okay, last one, well, second to last one, we have 14 pi ninths. So this one might be a little bit tricky for some people because you don't know where it lands. So what I did here is I kind of made some notes. Remember that when we're doing different numbers besides 6, 6, 3, 4, or 2, as a denominator, we can kind of subdivide the top by that many pieces. So you could say, well, let's do 9 pieces up here, 9 pieces down here, and see where does 14 land. So it'd be kind of like 9, 10, 11, 12, 13, 14. So it's somewhere over here, okay? I kind of used a little bit of math. I said, well, I know that 14 pi ninths is 1 pi and 5 pi ninths. So in other words, this one is a pi, and this right here is 5 ninths. So 5 ninths is definitely more than the halfway point. Okay, if that makes any sense. This is just my math with fractions. So I know that for sure it's going to be somewhere down here. Okay, somewhere down here. But since that 5 ninths, if I were to divide this piece down here into 9 pieces, well, 5 is going to go and it's going to be bigger than this part, right? Because 4.5 is half of 9. So it's going to have to land somewhere over here. That's where I figured out where this lands, okay? Once we've done that, we can see that this angle is closer to 2 pi than it is to pi. So that's what I'm going to subtract. 2 pi minus 14 pi ninths. And that gives me the following. We have to change 2 pi into, common denominator. So I multiplied this one times 9 to give me the common denominator of 9. And that gives me 18 pi over 9. Subtract, we get 4 pi ninths radians, which is our theta prime. Okay, that's going to be our reference angle. And last but not least, we did do one negative angle just in case you see this. This is negative 135 degrees. So remember that with negative, we are going backwards, which means this would be 0. This is negative 180. This is negative 360, also known as negative 2 pi, because some of you were asking about that in the email. So for 135, well, I know this is negative 90, so negative 90, 135, there's my angle, okay? Which means we have to find this piece, because this is closer to this side than it is to this side. So what I did is I took, well, I kind of thought, I said, how many more degrees to get from 135 to 180? And I did do it positive because, well, the negative, even though this is a negative angle, we're still trying to find just the distance from here to here, okay? So my reference angle for this is going to be 180 minus 135, and that's going to give me 45 degrees, which would be the reference angle from here. Yes, okay? And that's it. That's it for that one. What I should probably note, if you do use 45, I made it positive, but we do have to keep in mind that it is in quadrant 3. So depending what they're asking for, if they're asking for like sine, cosine, or something like that, make sure you remember what the signs are for this, because that is important, okay? Let's go ahead and do the last example. We have example 5, evaluate each trig function. So cosine of 4 pi thirds, sine of negative 120. So this is what I was talking about, is sometimes when we're looking for cosine or sine or whatever of those angles, it's easier to just use the reference angle, okay? So I did that here. We noted that this is going to land in quadrant 3, okay, where cosine is negative. And again, this is part of that tab 3 in your foldable. So 4 pi thirds lands right here. And you actually have the answer to this in your foldable, but we're going to use the reference angle just to kind of see how it works. We can see that 4 pi thirds is closer to pi. So in this case, we have to subtract because we're going kind of backwards, right? We're saying, I want to know what this piece is only, this piece right here. So it'd be like this whole thing minus this piece right here, which gives me this left over. Okay, so it'd be 4 pi thirds minus pi. And if that's confusing, you can also think, well, what plus pi will give me that 4 pi thirds? Okay, so when you calculate this, again, more fraction work, we get pi thirds. Okay, so we do cosine of pi thirds, which is a lot easier to find because that's one of our very, very main angles to find. If you look in your foldable, the x value is 1/2. Remember, cosine is equal to x. Okay, so the x value is 1/2, but since we're in quadrant 3, well, we have to remember that cosine in quadrant 3 is negative, so it's negative 1/2. Okay, and last but not least, I keep saying that, but this really is the last one. Sine of negative 120. Note that this is also in quadrant 3, and we're going backwards. In quadrant 3, sine is negative because the y value in quadrant 3 is negative. Okay, so same thing, we go ahead and draw our angle going backwards, 120, negative 120. You'll notice that this is closer to the 180. So since we're going this way, we subtract, or you can also think of it as how many more degrees from this point to 180? Well, it's just 60. Okay, so 60 degrees. Sine of 60, if you look in your foldable for the coordinates, we're looking at the y value. Okay, it would be square root of 3 over 2. But since we're in quadrant 3, again, quadrant 3, y is negative. So this is negative square root of 3 over 2. And that concludes the video for 4.4.